welcome to my channel Chemica Chemistry Classes. As we are discussing organic chemistry chapter, now today's topic is nomenclature of organic compounds, right? So, as organic chemistry deals with millions of compounds, in order to identify them, a systematic method of naming has been developed, and that is IUPAC, right? IUPAC is International Union of Pure and Applied Chemistry, right? So on the basis of this systematic nomenclature, names correlated with the structure, as reader or listener can understand, this is the IUPAC. So before IUPAC, we said that we are discussing millions of compounds and they are named under IUPAC. But before the IUPAC system of nomenclature, organic compounds are assigned names based on their origin or certain properties. For example, we can take example of citric acid, right? Citric acid is named because it is found in citrus fruit, and the acid found in red ant is named formic acid, since Latin word for ant is formica. One more example is Buckminster fullerenes. This is what is this? This is C60 cluster, right? C60 cluster of carbon. So there are more examples of this, right? So in International Union of Pure and Applied Chemistry has suggested a scheme for giving systematic names to organic compounds on the basis of their structure. So we will discussing this today. So nomenclature on the basis of alkanes, right? So the first four members are named or known by their common name, right? First four method is methane, ethane, propane, butane. As you all know about their structure, these are the basic names, right? So the higher members start from their prefix that indicate the number of carbon atoms in the molecule, right? And end with only ane, right? They are ending with this, right? So the last three letters in alkane, what is this? A pentane. We are using the word ane in the last, right? Hexane, heptane. We are using ane. In which? In alkynes. In alkyl, what happened? In alkyl, alkyl group is obtained by removing one hydrogen. We have to remove one hydrogen and we get alkyl group from alkane. Like in this we use, as in alkanes we write methane, right? But in alkyl we write methyl. This is the difference, right? Ethyl, propyl, and so on. So some simpler substitute with branch chain are often given some common names like isobutyl, sec-butyl, tert-butyl, etc. So there are some rules which we are going to discuss. Rules on which naming depends of alkenes. First is longest chain rule. Longest chain rule. From the name we can understand what is this. The longest chain of carbon is chosen. We have to choose the longest chain of carbon and the compound is named as a derivative of the alkane. Second rule is lowest number rule. Lowest number rule. What is lowest number rule? Numbering of the chain is started from the end where branching gets the lowest number. We have to start the numbering from the end where branching gets the lowest number. Where branching one part gets the lowest number. Third is the preference to the substitute and the least number of carbon atom. That means numbering is started from the end which is nearest to the branch with the least number of carbon atom, right? And fourth one is the preference to the greatest number of substitute. The end of the chain which is nearest to the large number of substitute is taken to be the first chance. Fifth rule is alphabetical order of alkyl group. The substitute are named in alphabetic order respectively, right? So the names is methyl, dimethyl, trimethyl. They all are considered to start from alphabets. Last rule is proper way of writing, but a number or a letter are separated by hyphen and numeral by a comma, and then the entire name is written as a one complete word. From example we are going to understand this, right? I will give you one example so that understanding of these rules is easy for you, right? So I think so I have covered all the points from this example, right? First is the longest chain rule. You have to select one, the longest chain. If you count 1, 2, 3, 4, 5, 6. 6 carbon is here. So 1, 2, 3, 4, 5, 6, 7. So we are going to decide this chain. Which one? I will write 1, 2, 3, 6. This chain is selected because we have to select one, the longest chain, right? So lowest number rule is followed here. So preference to substitute the least number of carbon is performed here. Everything is there, right? So before naming this we have to write, this is not complete, right? This is complete. We are going to write 2. What is this? This is methyl. Methyl is on the 2 and methyl is on the 5. So 2, 5, dimethyl, and this is what? This is isopropyl. So 3 isopropyl, and this chain is heptane, right? So this is the way of writing this, right? Now we are discussing nomenclature of alkanes. First of all, there is alkanes, then alkynes. So IUPAC name is obtained by replacing the suffix "ene." We have to replace the suffix "ene" by corresponding alkane by "ene." This is all about the alkanes, right? This is all about the alkanes, right? So alkanes are discussed here. So now we are discussing the alkenes. The IUPAC name is obtained by removing suffix "ene." In alkenes we have to remove this suffix by "ene." This is the main point, right? So double bond gets the smallest number in the longest carbon chain. I will give you one example. So this is better to understand with the example, right? This. So double bond gets the smallest number in the longest carbon chain, and more than one double bond is indicated by ending the name with diene, triene. That's depend upon the number of double bond. The position of double bond may be replaced between the suffix "ene" and rest of the name. For example, we're going to name this compound. So we select this chain 1, 2, 3, 4 and 5, right? So this is what? This is 3-methyl pent 1 and 4-diene, right? So this is what? This is 3-methyl pent 1,4-diene. This is right. This is the case of alkenes. Now what is in the case of alkynes? We have to, as we have discussed the alkanes over here, this is the example of alkanes. In alkenes, we have to replace this suffix by "-ene". In alkynes, we have to replace the suffix by "-ine", right? So for example, I will give you one example, like in CH. These namings are done according to the rules which we have discussed, right? So first we have to start the longest chain. So we are going to start from here as on the basis of rules. 1, 2, 3, 4, 5. So we have to name this compound as a 4-methyl pent 1-ine. This is the name of alkynes. This is for alkynes. In halogen, the compound is named as haloalkane, haloalkene, haloalkyne, depending on the nature of carbon chain. I will give you one example, like in CH3, CH. That is the we are discussing the case of halogen. First of all, we have to select the chain. And this is 1, 2, 3, 4 and 5. We named it as 4-bromo pent 2-ene. Because of the double bond, we are going to use ene. In case of alcohol, suffix ol replaces the e of alkene. Ol is used in place of e, as E is used in alkene, right? So that is all in alcohol, that is indicated by OH, right? So this is the example of alcohol derivative. Alcohol is represented by OH. So select the highest chain as 1, 2, 3, 4, 6, right? So this is 3-ethyl 3-hexanol. Ol is used instead of E. E is used in alkane and Ol is used in alcohols. Next is the case of aldehydes. In aldehydes, what happened? Suffix al is replaces the e of alkane, and the numbering of carbon atom is always done starting from aldehydes group. We have to number aldehyde group, and we have to start first number. We have to give the first number to aldehyde group, right? So CH2, and here you're using the aldehyde group. So 1, 2, 3, 4. 3-methyl butanol. I am writing here 3-methyl, that is butanol. In ketones, ON E replaces the E of alkane, and the numbering of carbon atoms is always done from CHO from aldehyde, but not in case of ketone. I will show you. In ketones, I will give you one example. This is a group of ol. This is ketone. It is 1, 2, 3, 4, 6, 7. So 4-methyl, because of this, 3-heptanone, that is 3-heptanone. Last में we have to add ONE. In carboxylic acid, suffix OIC. What is this? For carboxylic acid, suffix is OIC, that is going to replace the E, and the numbering of carbon atoms is always done or starting from the carboxylic acid group. Like I am showing this example. Okay, right, so this is what this is. 1 2 3, okay, 3 ethyl 3 methyl hexanic group, hexanic acid. This is what, this is of carboxylic acid group. In ether, these compounds are named as alkoxyalkanes. Ethers are named as alkoxyalkanes, and the smaller alkyl group along with the hydrogen atom is known as alkoxy group. So I will give you one example. So numbering is starting from here to towards this, and this is 2 ethoxy 5 methyl hexane. In amines, primary amines are named by replacing the ending E of the parent chain by amine. We have to write the amine. But in case of primary amines, the position of NH2 is indicated by the number. Secondary and tertiary amines are named as unsubstituted derivative of primary amine. For example, this is 2, right? This is 2 propane amine. And in the case of tertiary and secondary, what happened? We have to use the substitute N-methyl 2-propane amine. In cyanides, these are named as alkene nitriles, and the numbering indicates the nitrile carbon atom. An example is CN indicates the cyanides, and example is butane nitrile. Nitro group is what? Nitro group is represented by NO2, and in writing their name we use the word nitro, right? So example, NO2 group, that is nitro group. This is what? This is 4-methyl-2-nitropentane. Sulfonic acid. Sulfonic acid is, we have to write the name sulfonic acid while writing their name, and I will give you one example related to sulfonic acid. Sulfonic acid is represented by writing this. This is what? This is 4-methyl-1,2-hexane sulfonic acid, right? So in what happen in the case of polyfunctional group, when there is a 2-3 functional group, yeah, we said polyfunctional group, then how will you write the name, right? I will give you one example for this polyfunctional group. This is very simple. Okay, we will write 3-hydroxy 2-methyl pentonic acid, right? So prefix, like for Cl we write chloro, for Br for bromo, for I for ido, different suffix. In such compounds, what happen? One functional group is taken as principal functional group and other are treated as their substitute. In order of preference of principal functional group is like, first of all we have to find the carboxylic acid, then sulfonic, then ester acid, halide, amide, nitrile, aldehyde, ketone, alcohol, amine, etc. Right? So the compound containing double or triple bonds are called Ines. They are called ines. Okay. Next is the nomenclature of benzene derivative. Okay. So there are three different ways for writing benzene derivative. First is when substituent is in the benzene ring, so they are considered as benzene derivative. For example, this. This is 1 chloro 2 methyl benzene. Next case is the first case. Next scheme or next case is when substituent is in one or more carbon attached to carbon. These are considered as phenyl substituent, like this. This is what? This is phenyl chloromethane. Right? This is phenyl chloromethane. Some derivatives are named as per their common name, like this. This is what? This is phenol. This is one more example is benzopentane. Next is acetophenone. So there are lot of example for this. So this is all about the nomenclature of organic compounds with different functional groups. Thank you.